According to the 2020 National Electrical Code, there is no blanket requirement that all residential wiring must be a minimum of number 8 American wire gauge. The NEC focuses on ensuring that the wiring has sufficient ampacity, which is the current carrying capacity, for the loads it will serve. This means the wire size is determined by the amperage of the appliances or equipment it will supply. For instance, a 50 amp range circuit, a common application for larger gauge wire, requires careful consideration of the appropriate wire size. In this situation described, using number 8 American wire gauge copper wire for a 50 amp range circuit protected by a 40 amp overcurrent device is a common practice. The NEC mandates that the ampacity of the wire must be at least 125% of the continuous load. While a range isn't always considered a continuous load, this principle guides the selection of wire size to ensure safety and prevent overheating. Number 8 American wire gauge copper wire typically has an ampacity of around 40 to 55 amps, depending on the insulation type and installation conditions. The NEC Table 310.16 provides ampacity ratings for various wire sizes and insulation types. When selecting wire for a 50 amp range, it's essential to consult this table and consider factors like ambient temperature and the number of current carrying conductors in the raceway or cable. These factors can require directing the ampacity of the wire. Although number 8 American wire gauge copper is often suitable for a 40 amp overcurrent device, it's crucial to verify that it meets the specific requirements of the installation. The type of cable used also plays a role. NM, or non-metallic sheet cable, commonly known as Romex, has different ampacity ratings than individual conductors and conduit. NM cable's ampacity is often limited by its insulation temperature rating, typically 60 degrees Celsius. This can result in a lower ampacity rating compared to conductors with higher temperature ratings. When using NM cable, it's crucial to adhere to the ampacity limitations specified in the NEC. In some cases, using a larger wire size may be necessary to meet the ampacity requirements. Aluminum wire is also used in residential wiring, particularly for service entrance conductors and larger branch circuits. Aluminum wire has a lower ampacity than copper wire of the same gauge. For example, number 8 American wire gauge aluminum wire has a lower ampacity than number 8 American wire gauge copper wire. When using aluminum wire, it's essential to select a larger gauge to achieve the required ampacity. Aluminum wire also requires special considerations for termination. Aluminum expands and contracts more than copper with temperature changes, which can lead to loose connections and overheating. To prevent these problems, aluminum wire should be terminated with connectors specifically designed for aluminum conductors. These connectors are typically made of aluminum alloy and are coated with an oxide-inhibiting compound. The NEC provides specific requirements for the installation and termination of aluminum wire in Section 110.14. The overcurrent protection device, such as a circuit breaker or fuse, is designed to protect the wiring from overloads and short circuits. The overcurrent device should be sized to protect the wire based on its ampacity. It's crucial to select an overcurrent device with an ampacity rating that does not exceed the wire's ampacity. For example, if using number 8 American wire gauge copper wire with an ampacity of 40 amps, the overcurrent device should not be rated higher than 40 amps. Using an overcurrent device with a higher rating can allow the wire to overheat and potentially cause a fire. The NEC also addresses the use of screw connections and lug connections. Screw connections are commonly used for smaller wire sizes, while lug connections are typically used for larger wire sizes. Lug connections provide a more secure and reliable connection than screw connections, especially for larger conductors that carry higher currents. The NEC requires that conductors be properly terminated to ensure a reliable electrical connection. Improper terminations can lead to loose connections, overheating, and potential fire hazards. All electrical work should be performed by qualified individuals who are familiar with the NEC and local electrical codes. Electrical work can be dangerous, and it's essential to take precautions to prevent electrical shock and fire hazards. When working on electrical circuits, always turn off the power at the circuit breaker before beginning any work. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you're not comfortable working on electrical circuits, it's best to hire a qualified electrician to perform the work. The NEC is updated every 3 years, so it's essential to stay current with the latest edition. Local electrical codes may also have additional requirements that must be followed. By understanding the NEC and local electrical codes, you can ensure that your electrical wiring is safe and code compliant. Furthermore, always consult with the authority having jurisdiction or urge for clarification on any electrical code requirements. The AHA is responsible for enforcing the electrical code and can provide guidance on specific installation requirements. They can provide clarifications and interpretations of the code, ensuring that your electrical work meets all applicable requirements. Seeking guidance from the AHA is especially important when dealing with complex or unusual electrical installations. They can help you navigate the code requirements and ensure that your installation is safe and compliant. Remember that electrical codes are in place to protect people and property from electrical hazards. Adhering to these codes is crucial for ensuring the safety of your electrical system. By following the NEC, local electrical codes, and seeking guidance from the AHA, you can create a safe and reliable electrical installation. The ampacity of a conductor is influenced by several factors. Firstly, the material of the conductor plays a significant role. Copper has a higher conductivity than aluminum, which means it can carry more current for a given size. Secondly, the insulation type affects the ampacity. Different insulation materials have different temperature ratings, which determine how much heat the conductor can withstand. Thirdly, the installation method influences the ampacity. Conductors installed in free air can dissipate heat more easily than conductors installed in conduit or cable, resulting in a higher ampacity. Fourthly, the ambient temperature affects the ampacity. Higher ambient temperatures reduce the conductor's ability to dissipate heat, lowering its ampacity. Finally, the number of current-carrying conductors in a raceway or cable influences the ampacity. When multiple conductors are bundled together, they generate more heat, requiring a reduction in ampacity. The NEC provides tables and guidelines for adjusting ampacity based on these factors. It's crucial to consider all these factors when selecting the appropriate wire size for an electrical circuit. Failure to do so can result in overheating, insulation damage, and potential fire hazards. Therefore, a comprehensive understanding of ampacity and its influencing factors is essential for safe and code-compliant electrical installations. Now, delving deeper into the specific application of a 50 amp range circuit, let's consider the demand factors that can be applied. The NEC allows for demand factors to be applied to the calculation of the service or feeder size for ranges and cooking appliances. This is because ranges typically do not operate at their maximum rated load continuously. Demand factors recognize that the simultaneous operation of all range elements is unlikely. The NEC Table 220.55 provides demand factors for ranges and cooking appliances based on the number of appliances served. These demand factors can significantly reduce the calculated load for the service or feeder, allowing for smaller conductors and overcurrent protection devices. However, the branch circuit conductors supplying the range must still be sized to carry the full load of the range as determined by its nameplate rating. The demand factors only apply to the service or feeder supplying multiple ranges. Therefore, for a single 50 amp range, the branch circuit conductors must be sized to carry at least 50 amps, and the overcurrent protection device must be sized accordingly. Although the demand factors can reduce the overall load calculation, it's crucial to ensure that the branch circuit conductors are adequately sized to handle the maximum potential load of the range. When dealing with electrical installations, it's always best to err on the side of caution and consult with a qualified electrician. They can assess the specific requirements of your installation and ensure that all wiring and equipment are sized and installed correctly. Electrical work can be complex and dangerous, and it's essential to prioritize safety. By seeking professional guidance, you can avoid potential hazards and ensure that your electrical system is safe and reliable. In addition to the NEC and local electrical codes, there are other resources available to help you understand electrical wiring requirements. Electrical training programs, industry publications, and online forums can provide valuable information and insights. Staying informed about the latest electrical codes and best practices is essential for anyone working with electrical systems. By continuously learning and expanding your knowledge, you can enhance your skills and ensure that you're providing safe and reliable electrical services. Remember that electrical safety is paramount. Always take precautions when working with electrical circuits, and never hesitate to seek professional assistance when needed. By prioritizing safety and adhering to electrical codes, you can protect yourself, your family, and your property from electrical hazards. In conclusion, while there isn't a blanket minimum wire size of number 8 American wire gauge for all residential wiring, the appropriate wire size is determined by the ampacity requirements of the circuit. For a 50 amp range, number 8 American wire gauge copper wire is often acceptable when protected by a 40 amp overcurrent device, but it's crucial to verify that it meets the specific requirements of the installation and consult the NEC for ampacity ratings and dirting factors. Always prioritize safety and consult with a qualified electrician when performing electrical work.